Hello everybody, welcome to our last class, the third and the last class of arrays. And in today's class, we'll learn a new concept called array multidimensional. And it's very interesting. And let's see if I can make it easier for all of you. So I will try initially to work in some uh, diagram and representation so we can visually understand the idea, and then I'm gonna show some code later on. So let's start by, okay, when you are talking about one dimension, we just use open and close bracket. Okay, dimension, what did I dimension? It's just open and close bracket. And that is what we saw up until now. So let me do a copy and paste here. So in memory, oops, sorry, not this, I need to do this. So in the memory will be something like this. Oops, sorry, here. Let me give the full size. So I have this array already drawn. So will be something like this. And we got that from the last class, and we understand there is example there. So I think it was clear. When we go to two or more dimension, that means for every dimension, we will use an index. So in this case, it's like unidimension. So just one index is enough to address any element in the array. So looks how cool it is. This is. So let's go to two dimension now. So two dimensions, instead of just one open close bracket, we put two. So it's one open close bracket for each dimension. So one representation of this will be something like this. Let's just see if I can make this happen. So remember here, we have one dimension, but in that dimension, we can choose the length. How many elements were there? So if 10 or 1000 is just one dimension because we just need one index to identify or access any element in the array. Two dimensions, the same thing. For each dimension, we can have the size that we like. So imagine that for this first dimension, we use like 3. So let's make something like this, and let's divide like in 3 parts. So what will happen here is we have one dimension, and imagine that the dimension is 3. And then the second dimension is 10, is like what we have here. So would be something like this. What usually call matrix, because it's like a table. We'll have like this, and then this, and this. Okay, and let me still do some errors here. So each one of those positions will be pointing to one of those arrays. So at the end, we always have like one unidimensional array, but maybe n times. So this first index here, like the other arrays, will be 0. Oops, sorry. What is going on? Uh-oh. So it'll be like 0. Oh, I'm right. So it'll be 0, 1, and 2. And we already know that those ones from 0 to 9. So how do we access this element here? Will be similar. However, now we will use like, imagine that our array is called A of array. We'll say, what is the first index? 1. What is the second index? Is 7, 8, 9. So it's 7. Because look, 0, 1, 2. So we want this one in the middle. So it's the the first dimension is 1 and the second dimension is 7. And I missed this here. Okay, what will be this element here? A, 2, and 5. So it's just, we need just to follow. So will be A, 2, 0, 1, 2, and then 5. 0, 1, 2, 3, 4, 5. So it'll be, oops, sorry, not this, will be this guy here. So it'll be this element. So now if you want to loop through all the elements of the array, this one we could just have a single for 0 or till the end. And now we need two indexes. One to go from this array and another one to go to each one of elements of this array. So it'll be a for loop inside a for loop. Now is where things start to get interesting. What if we talk about 3 dimensions? So remember, is 1 open and close brackets for each dimension. Oops. Come on. 1, 2, 3. Now I have space to grab. Why is not grab? No. Okay. Imagine that in this case we are doing like 3 of this. So the values will be like 3. Let me do this. 3. No, I'll put 4. 4, 3, and 10. So look that this is a 10, 3, 10 already. So when you make 4, 10, 10, it will be something like this. Let's see if I can represent in a nice way here. I'll get this guy here. And I'll have it like 4 times. So it'll be 1, 2, 3, and 4. And for each one of those, we'll have another index. So this here, let me change this. This one here will be 0. This one will be 1, 2, and 3. And just put some separation. This guy is what is in the left. This is what is here. This is what is here. So now how we address this element here? So let's go there and see. It will be array 0, 1, 2. In 2 will be 0, 1. And now will be 0, 1, 2, 3, 4, 5, 6, 7. 7. Okay, so look, it's the same idea. Let me move this here to the corner so we can do so. I put here. So let's go crazy now and let's create a 4th dimension. So what if we do something like this? 4th dimension. And just for the sake of space, I put like 2, 4, 3, and 10. That means that we're gonna get wherever we already have here. Oh, let me copy this better. Let's see if I have space. And we're gonna have 2 eyes. So I'll kind of do this. I think I have a little bit of space here. And I will do this. Wait, I did something wrong here. I just put to the right a little bit. Another one. And we'll have 0 and 1. So what's changing now? For example, this element here will be, let me, where is the point? Just make sure we are talking about this one, right? Not sure if I put this one here. So it'll be, in the main first dimension will be the 1. In this dimension will be 0, 1, 2, 3. In that dimension, the 3 will be 0. And in that 0 will be 0 and 1. Okay, so if you want to scan all the elements of an array, of multi-dimensional array, we'll need as many as 4 as dimension you have. If you have only one dimension, one loop is enough. If you have 2 dimension, or what called matrix, we need 2 fours. If we need like, this is like, oh, we have any matrix now. So here is a matrix is we have any arrays. In a matrix, in a 3-dimension, we have any matrix. In a 4-dimension, we have any matrix. I hope that this didn't confuse you, but it's a very simple concept. So you can say, when we use this, well, wherever you need it to represent something like this. For example, imagine that you have a building that has floor plans, and you have one matrix representing the area of one floor, and then multiple floors. Imagine now that you have another building, so you add another dimension. Maybe 2 complex of buildings, so you have another dimension. So we'll change now to the code, and you see some example that will make easier for us to understand. So I hope I didn't confuse you with all those diagrams, but I think it's a nice visual representation that what those dimensions means. Most important thing, for every dimension, we have a new index. One single dimension, we just need one index because it's a collection of elements. 2-dimension, we call matrix because we need 2 index. So it's kind of a table, an Excel table. Remember that in Excel, we can use 2 line and rows, rows and columns to find a cell. It's the same idea. In 3, 4, any dimension, we just add another index. So we're gonna have like a more complex structure, but at the end of the day, it's just an array multiple times. Okay, so let's go to our code and see what we have in there. We are here. So, okay. So let's see what I prepared. So in the code, I say, okay, I want an integer array of array. So that is a matrix. In Java, they call this jagged array, when you have like an array of an array. And I say a b-dimensional. And I can even initialize. So I have like for every row, an array. Those arrays not necessarily must have the same size. So I could have something like this. This is valid as well. Just for sake of representation, I will do like this. In this case, I am already initialized the array and I give in all the values. Otherwise, I need to initialize with the code. Okay, and then I say print array bidimensional. So let me put the breakpoint here and you can run already so we can see what is going on. Let me increase this a little bit. I will do a right click and debug. The first line will pass. Look that even the runtime is going line by line of that because it's basically create those So when everything is created, then we'll see here bidimensional array. And look, is one array with 4 elements, and each element is another array. Okay, and then we're gonna say, okay, print an array that is bidimensional. So let's go inside this method, and like I said, we need 2 fors. The first one, using the variable I, we go all the way to the length of the array. And the thing is, as we don't know what is the size of each array, we can use this property of length. I say, okay, when I am in the internal for, I say j will start in 0 and will stop wherever is the length of that array. So in this case, I is 0. We are in this first line. And then I get the size of this. So when we go all the way to the end of the internal for, we finish, and then we go to the next one. And this is the trick to get what is the length of the specific array or dimension that we are. And what we're doing here, we are just printing every array or every element, put a space at the end. So when we finish the internal for, we print a new line. So we go to the next line and we do the same again for the second array. Okay, so let's get out of this method and we can see that we printed the entire array there. Now what I'm doing is I'm created three-dimensional array. So what I did there, like visually, I'm doing here with code. So what I did, I put like 4 matrix. So let's just put a breakpoint here. And if you go, look what happened here. We have that initial one, tridimensional, that has like 4 elements, 0, 2, 3. So it's 0, 1, 2, 3. If we open one this, we have another like element, and for each one we have the rows. So this guy has 0, 1, 0, 1, 2, 3 elements. 0, 1, 2, 3. Oh wait, why is 4 there? Oh no. 0, 1, 2, 3. Each one of those has the elements 10 to 14, 15 to 19. So if we go to the last one, we have that. So the same, if we go to the logic to print, we need like 3 fors now. So nested for, and we're gonna do something similar. For each array, we find out what is the length of the current array. So this one is the array, this is the length of the array I, and this is the length of array ij. So then we do the loop through, and what we're doing here is, like the other one, we are printing each one of the arrays. Let me just, I'll put a breakpoint here. One here, one here, one here. So when we finish one line, we go to the next line. Oops, sorry, let me go back there. And then we print another line, another line, another line. Now we finish one of those matrices. So we finish like the first one, 10 to 29. Now we're gonna give a space and print 20 or 30. Line by line. So it's just follow the algorithm. So it's not a big deal here. So this is kind of like a basic operation that we can do with array. Now we are just visiting every element and just print those elements. So let me remove the breakpoint and let it go. I confess that unidimensional array is very common when you are learning, doing practice, but bidimensional as well. There is many algorithms that we can do like amazing, like how to build a maze or find paths, or it is common. More than 2-dimensional is very rare, but it's not hard to understand. So if you need, you have another tool in your toolbox to use it. What we'll do now is I prepare one demonstration just to help you to really retain information about this array in multidimensional array. So imagine that we work in a climate, like a weather channel, and we need to store information about precipitation per month and per state. So what you have? First, we have an array with months. So we have like from January to December. So we know here that 0 is January and 11 is December. And just as a quick demonstration, we have an array, unidimensional, called precipitation per month. And here is the precipitation each month. Let me put a breakpoint and then we can already debug this and this thing. So debug Java. So in the first line, we are initialize an array with all the months. The second line, we are putting what is the precipitation each month. We don't know which state is this, and where is this. And now let's say, okay, let's use this information because look, we know that January is 0. So we can use the same index to show the string January and what's the precipitation in January. 5 something, I don't know. I know nothing about weather, so I guess this is like a good example. So let's look at the terminal here. I'm gonna say that January we have 5. February we have 3. So this is just an easy way to store information about each month's name, description, and how much precipitation we have that month. Now let's go to another example. That is, imagine that why you need a new dimension. That is a good example. We had precipitation per month, but now we need that information per state. I'm showing here just 4 states, just for the sake of the size of the demo, but we could have all states. So now we have a new array called states that has all those 4, California, Florida, Nevada, and Texas. And we have now for each state, not for each state, at each index, some values. So when we go here, what we're doing is, that means for California, we have this precipitation in January and this in December and so on. Okay? Imagine that now we need to build a report that we want to print for each state what was the precipitation per month. So what we're doing here is we will build a loop on all the states array. For each state array, we will print the state name. And as we know, this other array, precipitation per month, has in the index 0 all the precipitation for California. So we're going to loop through and print all the precipitation to California. So let me put a breakpoint here. I will let it run. And you can see now that you have precipitation California. Now we are in the second phase of this external loop, and the I now is 1. So we are in this state that is 1 is Florida. So we will print Florida and all the precipitation for every month of Florida, and so on. This is just an example to help you to understand. So what you could do to understand, do an hour or exercise to, I'm gonna add this to the exercise list. Okay, so what is the average precipitation for January, regardless of the states? What was the maximum precipitation in December for all the states? So we can build the logic to access those arrays. So this is the kind of problem that you can solve using those arrays. We can have that information, and then you can run some code to get that information. Okay, so like I said, I will put a reference for all this code that we use. It's a GitHub repository plus the exercise, and try to solve it. If you have any trouble, just post a comment there that I will help you on that. Okay, cool. Well, thank you and enjoy the learning.